I'm preparing you for college, and in college you don't get reviews. Okay?
Disgusting.
Yeah, in college you have to do 90% of stuff.
I'm gonna run for president and instead of free college, I'm making college reviews and managing.
Just ask your teacher really nicely for
Okay, so pretty soon we're going to talk about functions being approximated by a polynomial, and we'll specifically talk about this example. But what we did on Tuesday, we talked about non-polynomial functions and how we could use them to approximate at a center. Yes?
I don't see how you would get any terms out of that because you get x e to the x, which would be 0, and 0 times x is 0.
Well, if we centered at 0, e to the 0 is 1.
Yeah, so you get the first term, but then
And
f
then the derivative would be e to the x.
times
And-
x.
Right, so e to the 0 is 1, so you have 1x. And then your next derivative would be e to the x, and e to the 0 is 1, so you have 1 over 2 factorial x squared.
Oh, that's right.
Do you see where I'm going with that?
Oh, I thought it was x times e to the x stuff. E to the x squared would cause that to happen.
These are things we already know, right?
Yes.
Write this down.
Yes.
Okay.
Yes. The more terms, the better the approximation.
Ah.
Okay? What we're talking about today is this interval of convergence. Okay? So the more terms
How long it's
equals a
exactly.
better of approximation over what we're going to talk about, an interval of convergence. Okay?
Is that how long
So
the
this is what Jackson was asking about the other day. Can we have a series with an x in it? And that's exactly what's going to happen. This is called a power series. Okay? So it's basically, on Tuesday I gave me a 5th degree polynomial, give me a 6th degree polynomial. Well, here a power series is we just keep on going to infinity. Okay?
But
So it's like taking this polynomial, but making it of infinite degree, okay? Instead of writing all of that, we're going to write it as this series, okay? And we can also do that centered at something that's not 0. I'm going to take these back to Mr. Olden while you write that down.
This is on. Victoria has it. It's just one question on it. It was the last question on the multiple choice test, and I was like, well.
Okay, now we have 3 options.
I don't get the point of these things.
For a power series centered at C, C could be 0. 3 things could happen. It only converges at C. Or it converges on an interval, And that's what I would write. I would not write all of this mumbo jumbo, but I would write it converges on an interval. And we'll talk about what that R means. Okay? Or it converges everywhere.
It has an infinite number of terms, then it would always converge everywhere. Because the interval would be infinite. Because the polynomial being infinite would just make it exactly match the function itself.
I disagree. So we are going to have x's and n's in our series. Okay? And we're going to sum up from n equals 1 to infinity. But there's going to be a restriction on what our x's can be in order for this to be a legitimate series.
Oh,
Okay?
so C is dependent on the value of x.
Well, C is where we're centered. But this, how far out we can be with our convergence, depends on
Value of x.
right, and we're gonna use the ratio test to help us. Okay. So here's what is going to happen. Let's talk about R. Capital R. Capital R is what we call our radius of convergence. Okay. Now, our radius of convergence, that's how far we're going to go out from the center. Okay. And we have now 6 different options that can happen. Okay. I'll tell you what it looks like for R if we have like the single point or an entire line, so hold off on those. But when we look at our radius of convergence, we will also have to take into consideration, do we converge at the endpoints or not? Here's where those other tests, besides the ratio test, will help us. What would our radius of convergence be here?
0.
0. What would our radius of convergence be here?
Infinity.
Okay, so that might be a good thing to write down. Okay, so if you want to just add that to the picture or however you want to write it down.
Wouldn't it just be easier to use the actual function when you're approximating?
Yeah, but we're doing Okay, so I could ask you one of two things. I could ask you for the radius of convergence, or I could ask you what the interval of convergence is. Okay, the radius of convergence is just finding the number, and then the interval of convergence is taking that number in conjunction with the center and figuring out if it converges at the endpoints or not. So we're going to start out and we're just going to find some radius of convergence answers. Are you ready? Please write down this series. Anytime you see what is the radius of convergence, what?
Wow. I was like, what the? I'm sorry.
Anytime I ask you to find the radius of convergence, you're going to do so with the ratio test. Like, no other way. Just do the ratio test. Okay? Joe.
Is what the limit reaches the radius of convergence?
Not exactly.
Okay.
Okay. So let's talk about our limit. That's an arrow. Okay, so we would have 2x to the n plus 1 over n plus 1 squared, right? Divided by a sub n.
Two x to the n. Not just two.
Good point. Thank you. Okay, so if we want to take this limit, we like to scrunch these guys together. And then 2x to the n plus 1 divided by 2x to the n would leave us with just 2x to the first. Do you agree? Okay, so this goes to 1. And what would our limit equal? 2x. The absolute value of 2x, right? But whatever. Okay. Well, if we're doing a ratio test, what do we want our limit to be if we want convergence?
Less than 1.
We want it to be less than 1. So we want the absolute value of 2x to be less than 1, which means we want the absolute value of x to be less than 1/2. So our radius of convergence is 1/2.
Non-inclusive.
Well, we don't know that yet.
Well, if it is 1/2, it equals 1.
But then that means the ratio test is inconclusive. Sorry, I understand what you're saying now. When you said non-inclusive, I was thinking of parentheses versus brackets. And that's why we will have to test the endpoints because the ratio test is inconclusive at 1. Okay? But we're not quite there yet. Let's do one more, find the radius, and then we will worry about an interval. Okay? So this one's slightly different. Oops. Needs to be n towards infinity. Okay, so we have 2x to the 2n plus 2, right? Over 2n plus 2 factorial. Is everyone okay with what I have written up there? If n is multiplied by that 2, then n plus 1 also has to be multiplied by that 2. Right? Gabe, did you have something to say, or are you just talking to yourself? Okay. So if I group 2n factorial over 2n plus 2 factorial, do you agree that we'd be left with 2n plus 1 times 2n plus 2? Because the rest would cancel out. And then we would have 2x squared left over.
So we have 2x squared times 0.
We do. Our limit is 0. And how often is 0 less than 1?
Always.
All the time. So what's our radius of convergence?
Infinity. Well, this is
Yeah, it's not that bad. Okay. Now we're going to go back to both of these series and talk about what the interval would be. Yes.
Okay, so is how you test the endpoints doing the nth term test while plugging in the value of the radius as endpoint for x?
Almost. It wouldn't always have to be the nth term test. It could be any of the tests. But yes, we're going to plug in our radius for x. So let's come back to this guy right here. Okay. We are going to use the radius to get the interval and then check our endpoints. So you already have this written down with the work, right? So go back to that. Or draw an arrow if you need to. Okay. Where are we centered at? 0, because you don't see plus a or minus a or anything like that. So we are centered at 0, which means if we're centered at 0 and we go to the right 1/2 and to the left 1/2, we're talking about an interval from -1/2 to +1/2. Okay. Now it's a matter of, do we converge there?
Well, one's going to be an alternating series.
Okay. So if x equals -1/2, then we are looking at the series from n equals 1 to infinity of 2 times -1/2 is -1. Okay. At this point, if it is inside of interval convergence problem, you don't need to show me all of your work. Do we know that this converges? By what? Then just tell me that you thought about those things. Okay? If I ask you, show me that if this converges or diverges like I did on your quiz the other day, I would want to see all the work. But now that we're in the middle of a problem, let's just make it quick. Okay? So we can put a bracket there. If x equals 1/2, then we're talking about n equals 1 to infinity of 1 to the n over n squared. What's 1 to the n? Okay. So we really have, thank you, we really have 1 over n squared. And what do we know about that series?
It's a converging p series.
It's a converging p series. So we can put a bracket there. That would be our interval of convergence. Questions?
Seems pretty simple.
It's not so bad, is it?
You just use the ratio test, and then if you get an actual number that isn't 0
Mm-hmm.
or
Oh, I'm sorry. 3 more seconds.
We're going to talk about the second example's interval of convergence.
Thank you.
You're welcome. What was the radius of convergence for example number 2?
infinity,
Oh, so what's our interval?
negative infinity to infinity.
Ah. You should get excited about that.
No extra work.
What would your limit of the ratio test need to be if you were going to only converge at the center?
Infinity.
Because
What if it's
infinity
just-
is never less than 1.
What if it's just a number that's greater than? Oh, if it's greater
Well,
than you have to.
It'll
has to do
involve
with the
x. Okay, it'll involve x, so you'll always be able to solve for it. Okay, so now let's look at one that is not centered at 0. How do we know that this one is not centered at 0?
There's the 5.
Because you see x minus 5 to the n. Okay, this is centered at 5. Okay, do we have it all written down? There's a lot of it. Okay.
Yes.
Now we're in. So let's do our ratio test. We have the limit as n approaches infinity of -1. Do we really need the -1 baloney? No, because we're at an absolute value.
So we can just skip over that.
Yeah. Okay. So we know we have x minus 5 to the first left over, right?
Yes.
Over 5, right? The 5 to the n over 5 to the n plus 1 will leave a 5 in the denominator. And we have n over n plus 1. Okay. So this guy would go to 1, right? And our limit would be the absolute value of x minus 5 over 5. Because that's what we have left, right? Well, what do we want that to be? Less than 1. So we need the absolute value of x minus 5 to be less than 5. That 5 is our radius of convergence. If we are centered at 5, our interval would stretch from
0 to 10.
0 to 10. Because from 5, we need to go down 5 and up 5. So our interval is going to go from 0 to 10, but we got to check the endpoints.
That looks like it'll be nice.
Okay, so let's first check if we have x is 0. Sometimes you will need to get slightly creative when you are doing your simplification. Okay, what do I mean by that?
Factor in a -1.
Okay, I have a 5 to the n here, and I can split this up to be a 5 to the n so they can cancel. Okay, so we can split this up to be -1 to the n and 5 to the n so that those can cancel. So really we have -1 to the 2n plus 1. Well, what kind of number is 2n plus 1 all the time? Odd. So this is always -1. So this is not an alternating series. This is a p series.
And it diverges.
Yeah, what would you
What, Gabe? Did you have a question?
Yeah, but there's no sense in that. It's okay.
He asked what happened, like, to the
I'm like
thing.
struggling with simplification and stuff.
Like from here to here?
Yeah.
Okay, so Gabe, -5 to the n. -5 is -1 times 5. So I can split this up to -1 to the n times 5 to
Oh,
the
and
n.
then you added the -1.
And
Okay,
then
see,
the
so that's
exponents
the
get added
factors.
together. That's why you asked, so we can talk about it. It's not stupid. Okay? Are we okay with that being a p series? Okay. If x equals 10, hopefully this won't be as complicated, right? If x equals 10, 10 minus 5 is just 5 to the n. So here, our simplifying is much easier. And what do we know about that series?
Converges to the ultimate series.
Questions, comments, concerns?
Is this the whole gist of what a power series is?
Yes, there's one more thing we're going to talk about, but it's not going to blow you out of the water. It's not going to really change anything. It's actually going to save you some time. Would you like that?
Yes.
Yeah.
Can I write it? Can I write it in one line?
No. You know what? Sorry.
Are you
It'll be squeezing on the side.
Okay. If I ask you to find the interval of convergence for f, f prime, and the integral of f, I can save you some time because the radius will always be the same. It's more about the endpoints that you'll need to check from f to f prime and f to antiderivative f. Okay. Don't go through the ratio test again to find the radius. It will be the same, but the endpoints will probably change. So you'll need to recheck those. Okay, Mrs. Homan, how do we find a derivative of a series? Same way you would of a function. You ready? Okay. We are taking the derivative with respect to,
X.
so this n squared stays as n squared. But this is 2x to the n.
So we have
Oh, chain rule times 2. Okay. So here, our interval of convergence, well, we could simplify this, right? Which I would simplify this to be 2 times 2x to the n minus 1 all over n. Okay, your radius is still 1/2, which means your interval is still going to go from -1/2 to +1/2. You'll just have to recheck those endpoints now that we've had a little bit of an adjustment. Okay. Same thing with an antiderivative. If I want the antiderivative of this series, all we have to think about is how we would take the antiderivative of 2x to the n. What do we do? What's our power rule?
It goes
1 over n plus 1 times 2x.
Okay. And chain rule, We would also have to divide by that 2 since the 2's inside. Gabe, are you okay with that? No? What's your question?
I don't have a question. Usually mine is a copy. I'll have to go back to the later.
I have plenty of time for a question. Should I re-talk through that?
No, I have this part. I have a question about like one of the basic constructs and everything. I'm going up to this part that I'll ask you in class.
Okay, so 2x to the n, we increase our power by 1 while dividing by that power. And then since there's a 2 inside, we have to divide by 2. So if we simplify this so it's easier to check our endpoints, we would have, well, we can't really simplify. All right.
N cubed plus n squared times 2.
Well, that would be, yes, that is something we could do. But our radius would still be 1/2. And so you would still have the interval of -1/2 to +1/2, but you would just need to check the endpoints again with that. Okay? What will happen each time? You'll either get some sort of alternating series, or you'll not get an alternating series, okay? One of the two things will happen. It'll either be a -1 to a power, or it'll be a positive number to a power. You're just going to have to kind of finagle it around, okay? So your homework, EOO means
Every other, obviously.
every other on. Okay. I don't have a review for you because I don't want to overload you. Okay? Do your homework. Go back and look at the homework that you did yesterday. Okay? How many of you did your Lagrange error last night? Okay. See, so it's fresh. Go back and look at it. We'll talk 10 minutes at the beginning of class. It's okay. If you have questions, we'll ask them. We'll go over problems. Okay? The more often I quiz you, the more you're going to remember things.
goes,
The more you're going to remember. Would you rather have 2 weeks of material and then a quiz?
I just don't want to have a quiz.
You don't want to take home quiz?
I mean, like, I got the same accuracy on my take-home quiz I'll have on the quiz in class.
My dad made a shot.